Hello, pre-calculus friends. This is it. This is the last section of notes. This is pre-calculus section 12.3 notes, day 3. Today we're going to be finishing up our study of limits and derivatives by talking about instantaneous rate of change. So if y is equal to the function f of x, then the instantaneous rate of change of y with respect to x at some point x equals a is the limit of the average rate of change as x approaches a. Okay, so in definition form, IRC, which we abbreviate for instantaneous rate of change, is equal to f prime of a, which we know is the derivative of the function f at point a, which is equal to the limit as x approaches a of f of x minus f of a over x minus a. Wow, that ties together everything that we've done in section 12.3. Okay, so then we have a special case of the instantaneous rate of change. Consider the case where x represents time. So instead of using the variable x, we're going to use the variable t. Then f of t would be the displacement or the directed distance of an object at time t. For this, the instantaneous rate of change when distance changes with respect to time is called instantaneous velocity. Okay, you physics folks may have heard of that. All right, so let's do a little bit of tying things together here. Some important connections that I hope that you are making. The derivative, f prime of a, is equal to the slope of the tangent line to y equals f of x at the point x equals a. It's also equivalent to the instantaneous rate of change of y with respect to x at x equals a, which is also equal to the limit as x approaches a of f of x minus f of a over x minus a. And that was all in that definition in the top box there. Okay, so kind of tying things together here, we've got two ways to find f prime of a. Okay, the first way that we learned was the limit as x approaches a of f of x minus f of a over x minus a. And then the second way that we learned was the definition of a derivative. The limit as h approaches 0 of f of a plus h minus f of a all over h. So then the question becomes, well, when do I use the first one and when do I use the second one? Great question. Okay, so let's put a little note down about that. You're going to use the first one when you have a given a f of a point, because then the math is easier with that one. You are going to use the definition of a derivative when you're finding f prime of a for any generic a value. In other words, when you don't know what a is, that's when you have to use the definition of a derivative. So let's take a look at our last math example. It says, if an object is dropped from a height of 3,000 feet, its distance above the ground in feet after t seconds is given by h of t equals 3,000 minus 16t squared. Find the object's instantaneous velocity after 5 seconds. So this means they are asking us to find h prime of 5 because our function is h of t. Okay? So h prime of 5 is going to be equal to the limit, now remember our variable is t, so the limit as t approaches 5 of h of t minus h of 5 over t minus 5. I'm going to be using the definition of a tangent line for this one because I know the a value that I'm plugging in, or in this case, the t value that I'm plugging in is 5 seconds, okay? So it's going to look like this when I write it out. The limit as t approaches 5 of, now I'm going to be plugging, I'm going to do the h of t minus h of 5 over t minus 5. So h of t is just going to be the function with t in it. So 3,000 minus 16t squared minus h of 5 is what I get when I plug 5 in for t. So 3,000 minus 16 times 5 squared. And this is all going to be over t minus 5. All right, so obviously now I just have some math to do. So this is going to be the limit as t approaches 5 of 3,000 minus 16t squared minus 3,000, and then 5 squared is 25, and negative 16 times 25 would be 400, so negative 400 would make positive 400, and that's over t minus 5. Okay, so now hopefully you see I get to cross out the 3,000 and the negative 3,000. So in the next step, I am going to have the limit as t approaches 5 of negative 16t squared plus 400 over t minus 5. Now hopefully you're thinking about your bag of tricks, and I hope when you look at that you think, there's probably a GCF there because I'm probably going to have to do some factoring to eliminate that factor of t minus 5 in the denominator. And sure enough, the GCF is negative 16. So my next step is going to be to factor that numerator. So I've got the limit as t approaches 5 of negative 16, and then it's going to become t squared minus, 25 over t minus 5. And then that t squared minus 25, that is a difference of squares. So this becomes the limit as t approaches 5 of negative 16 times t plus 5 times t minus 5 all over t minus 5. And then of course I get to simplify and cross out those factors of t minus 5 right there and right there. So I end up with the limit as t approaches 5 of negative 16 times t plus 5. So then when I plug in 5 for t, I end up with negative 16 times 5 plus 5, which is negative 16 times 10, which is negative 160. Okay, so what does that answer mean? Okay, well, the instantaneous velocity after 3 seconds, this should say 5 seconds because we did 5 for t, not 3. The instantaneous velocity after 5 seconds is negative 160 feet per second. And I want you to note that the answer, that negative in front of the answer means that the height is decreasing at a rate of 160 feet per second. So just make sure you understand that what the negative is in the context of this problem. That's it, folks. That's all.